Okay, so we are recording, and again, I'm looking at the review right here. Let me load this up all the way. So the first question that somebody has is number 11. Before I get to 11, and I'll get there right now, but does anybody have any questions from the first, say, 10 that y'all want me to go through? And I'll do those, and then I'll get to, well, you know what? Let's do this. Let's do 11 first, and then we'll come back. Okay. All right, so I'll tell you what, let's do number 11 first, and then we can come back and take a look at anything else that we need. Okay, so let's do this. Okay, let me copy this guy here, y'all. And what I'm going to do is scroll down to the bottom. Okay, I'll tell you what, we'll do it right over here. Okay, let me, oops. Drop this guy right here. Okay. That's not what I wanted to do. Let me get rid of this. Boom. Let me just add a page. There we go. Okay. And let's paste that right there. Here we go. Okay, so it says find the greatest common denominator, or the greatest common divisor and the least common multiple for the following groups of numbers using the intersection of sets method. Okay, so what we're going to do, y'all, we have a couple of numbers here. We have 45 and 75. So the first thing I'm going to do, I'm going to think about how would I break down 45. So the two numbers that I know to multiply to 45 are 9 and 5, and I can break up 9 into 3 and 3, okay? And then 75, when I think of 75, y'all, I think of like money. I think of 3 and 25, like 3 quarters. And when I think of 25, I think of 5 and 5, okay? So this is what I'm going to do now. I'm going to draw 2 circles, okay? The circle over here, y'all, is going to represent the number 45, and this one's going to represent the number 75. And so the first thing I'm going to do is I'm going to say, look, this one has a 3, and that one has a 3. So that 3 is going to go inside. So I've gotten rid of this 3 and that 3. And this one has a 5 and that one has a 5. So that 5, since it's common to both, is going to go in the middle. And then this 3 over here is common to the 45, but not to the 75. And this 5 over here is going to go that way. Okay. So now my greatest common divisor, y'all, my greatest common divisor is always the product, meaning to multiply the numbers that we have in common. So the greatest common divisor is going to be 3 times 5, which is 15. And then the least common multiple is going to be those same numbers, 3 and 5, right, along with the other numbers. So when I multiply those numbers together, I should end up with 225, okay? And this, I'm gonna just kind of basically repeat this process, y'all, every time, okay? So look, let's do the same thing for 20 and 36, okay? So look, I'm gonna scroll back over here. I have 2 numbers. We got 20 and we have 36. Okay, so we wanna break them down. So 20, when I think of 20, I can say, look, it's 2 and 10, and 10 is 2 and 5. And 36, I can say, look, that's 6 and 6, and 6 is 2 and 3, and that 6 is also 2 and 3, okay? So I'm going to put 2 circles here, okay? Now, one of those circles is going to represent the number 20. The other one's going to represent the number 36, okay? So I want to see what numbers do I have in common, and the numbers that I have in common, y'all, are going to go in the middle part. So look, I have a 2 here and I have a 2 here. So a 2 is going to go in right there. Let me get rid of that 2. I have a 2 here and I have another 2 here. So that 2 is also going to go in the middle, okay? Now, what other numbers did I have in 20 that I hadn't used yet? Oh, look, that 5. So that 5 is going to hang out over there, okay? And what numbers did I have in 36 that I hadn't used yet? Oh, those 3s. So both of those 3s are going to hang out this way. Okay. So again, I'll do the same process, y'all. Look, my greatest common divisor is going to be the numbers that I have in common when we multiply them. 2 times 2 is going to give me 4. And then my least common multiple is going to be those same numbers, 2 times 2 times whatever else I have left over. 5 and 3 and 3. So let's see, that's 4. 4 times 5 is 20. 20 times 3 is 60. 60 times 3 is 180. Okay. Does that make sense on how I'm going about doing this problem? Yeah? Okay, so look, let's go ahead and finish it off. We got a couple more. So we have 8, 40, and 64. Okay, so we have 8, we have 40, and we have 64. Okay, so again, I'm going to break down the number 8. So when I think of 8, I think of 2 and 4. But when I think of 4, I think of 2 and 2. Okay. When I think of 40, I think of 4 and 10. Again, y'all, when you break these numbers down, sometimes people say, well, you know what? When I thought of 80, I thought of 5 and 8. You're going to get the same answers, okay? That's 2 and 2. That's 2 and 5. When I think of 64, I think of 8 and 8. But I want you to notice something, y'all. We already broke down 8 over here. 8 had 3 2s. So I'm just going to do this. 1, 2, 3. And this 8 also has 3 2s. 1, 2, 3. Okay. Now, what we're going to do is we're going to draw, in this case, y'all, we're going to draw 3 circles. Okay. So look, I'm going to go 1, 2, 3. Okay. And one of those circles is going to be 8. One of them is going to be 40. And that one there is going to be 64. Okay. So the first thing I'm going to do is I'm going to say, okay, what numbers do they all have in common? It looks like they all have 3 2s, right? They all have 3 2s. So those 3 2s, y'all, I'm going to go 1, 2, 3 right there. Okay. Now, I want you to notice for 8, there's no other numbers. Remember, I'm not looking at the 4 because we broke down the 4. For the number 40, there's one other number. It's a 5, and that 5 is going to go right over there outside of anything else because it's only for the 40 and nothing else. And these 2's here are going to go right there. Okay. So now we're going to do the same thing. To find the greatest common divisor, we're going to look at the numbers that they have in common. 2, 2, and 2, which is 8. To find the least common multiple, we're going to take those same numbers, 2, 2, and 2, remember, which we just said was 8, and we're going to multiply by whatever else we have. Well, look, another 3 2's really gives me another 8 and then a 5. So I'll say, what's 8 times 8 times 5? 320. Okay. And there's my least common multiple. Okay. And we're going to do this one last time, y'all, for the last pair of numbers, which are 5 and 9. Okay. So look, the last ones I have here, y'all, are 5 and 9. So 5, I can't break down 5 because it's already prime. 9, we can break down into 3 and 3. So I'm going to draw 2 circles. One of them is 5. The other one is 9. When I notice, y'all, I don't have any numbers in common. So the number that's always in common to both is 1. Okay. And this 5 will go here, and those 2 3's will go over there. So what's my greatest common divisor? The number that we have in common. And 1 is always going to be a number we have in common. And then what's my least common multiple? 5 times 3 times 3, which is 45. Okay. Okay. Let me come back to my review. Don't any other, so like I can enter those answers in 2. Oh man, let's come back over here. We'll just do the first part because we did them already. So 15 and 225, right? So I can come back here. 15, check it. Okay. I'm saying 225, check it. Okay. And we can kind of just keep going through the same thing, right? Let's check all the answers. What do I got here? 4 and 180 for the second one. 4, check it. Okay. 180. Oops. 180. Check it. Okay. And the next one here, I believe the greatest common divisor was 8. Yeah, and I forgot what the common multiple was. 320. Okay. And the greatest common divisor here, y'all, was a 1. And my least common multiple was a 45. And we got it, okay? But that's basically what they're asking me to do through that problem. Any questions, y'all, between 1 and 10 that anybody wants to ask me about? 10. Let's take a look at number 10. Okay, so it says, a woman with a basket of eggs finds that if she removes the eggs from the basket, either 3 at a time or 5 at a time, there's always 1 egg left over. But if she removes the eggs 8 at a time, there's no eggs left. If the basket holds up to 100 eggs, how many eggs does she have? Okay, so look, let's do this. Let me go ahead and copy this guy here, and we'll paste it into my notes so we can figure out what's happening, okay? So these are really good questions. I'm going to be asking these. Okay, so look, y'all, it says if we remove the eggs from the basket, either 3 at a time or 5 at a time, there's always 1 left over. Okay, so the idea behind division means that whatever your remainder is going to be the one that's left over. So look, I want to think about this. It says the basket does hold up to 100 eggs. Okay, so I'm going to start looking at multiples of 3. So multiples of 3 would mean like 3 and 6 and 9 and 12 and 15 and 18 and 21 and 24 and 27 and 30 and 33. And it's going to take me a little while, y'all, here. I'm hoping I don't have to go too far, but we'll figure this out in a minute. 45, 48, 51, 54. I'm going by threes. 57, 60, 63, 66, 69, 72, 75. Let's see, what else? 78, 81, 84, 87, 90, 93, 96, 99. Okay, I'm stopping there, y'all, because we know that it only holds up to 100 eggs, okay? Now, I'm going to do the same thing with the number 5, okay? So if I start thinking about multiples of 5, right? Okay, I like 5 better because it's easier to do, right? Let's try this. Okay, 5, 10, 15. Oh, come on. Oops. Let's get rid of that. Okay, 20, 25, 30, 35, 40, 45, 50, 55, 60, 75, 80, 85, 90, 95. Okay, I want to see, do I have any numbers in common here? Oh, let's see. 30? 30 is a number we have in common, right? Okay, 30 is a number we have in common. Okay, and do we have any other numbers in common besides 30? What about 45? Right, 45 is another one we have in common. And 60 is another one we have in common. And let's see, what else do we have in common? I'm sorry? 90? Yeah, 90 is another one we have in common. Oh, come on, pen. And what, 75? Right, 75 is the other one we have in common. Okay, so we got some numbers in common here. What we're going to do, y'all, we're going to look at those numbers there, okay? And if we think about this, every time we take out either 3 or 5, there's always 1 left over, right? So if I think about the numbers that I have in common, if there's always 1 left over, wouldn't that mean there would always have to be 31 eggs? Because if I take 3 at a time, I could take, say, 10 sets of 3, which would give me 30. But if there's 1 left over, that would mean that there's 31 eggs, right? Or there could be 1 left over, 46, 1 left over, 61, 1 left over, 76, 1 left over, 91. Okay. Now, we want to see, are any of those numbers there? divisible by 8. So what I would do now is I'd say, look, oops, 36, can I divide it by 8 nice and neat? No. Okay, 46, can I divide that by 8 nice and neat? No. 61, can I divide that by 8 nice and neat? No. What about 76? Can I divide that by 8 nice and neat? No. 91, can I divide that by 8 nice and neat? No. Okay, am I missing something here? Let me see. 76 divided by 8. 9.5. No, it doesn't go nice and neat. I thought it did. I'm missing something here, and I'm trying to figure out what am I missing. Oh, 15.
And 16 is divisible.
There we go. There we go. Yeah, I didn't see that. Okay, my bad. My bad, y'all. 15. 15 is a number that we have in common. If we add 1 to it, it's 16. We can divide that by 8, nice and pretty. Okay, there we go. So how many eggs does she have to have? Got to have 16 eggs. Okay, there we go. My bad. That's what we couldn't figure out. We forgot that first one. So she has 16 eggs, right? So look, y'all, I'm going to come back over here. Sorry about that, y'all. I just missed that. So look, 16 eggs. We're going to check it. Boom, and we got it, right? So there we go. Okay. But that's basically the process, yeah, on how we would do that. Good deal, good deal. Any other questions, y'all, between 1 and, say, 9? Anything there? Number 4. Let's take a look at number 4. Okay, it says a group of people ordered pencils. The bill was 55 cents. If the original price of each was 9 cents and the price has risen, how much does each cost? Okay, so let me do this real quick. Let's come back here. Boom. Let's copy this so we can figure out what we got to do. Okay. Okay, so let me paste this guy right here. Okay, and it says a group of people ordered pencils. The bill was 55 cents. If the original price of each was 9 cents and the price has gone up, how much does each cost? Okay, y'all, if my bill is 55 cents, I'm going to write it like this, like 55 cents, right? So I want to think of what two numbers would multiply to 55. Wouldn't it be 5 and how much? And 11, right? Okay, so the original price, so remember what this means. This would mean either I'm buying 11 pencils at 5 cents a piece, or I'm buying 5 pencils at 11 cents a piece, right? Okay, now look what it says. If the original price was 9 cents and it has gone up, how much does each pencil cost? So the question is saying, would the pencils cost 5 cents or would the pencils cost 11 cents? Well, if they used to cost 9 and it went up, they have to cost how much? 11 cents, right? So right here, y'all, we're just going to put the number 11. So we'll come back here. We're going to type in 11 and we're going to check our answer and we got it, right? Good. All right. Any other questions, y'all, between, say, 4 and 9, or do you want me to go past 11? 18? Okay, let's take a look at 18. Okay, so let me do this. Let me go ahead and copy this thing, and we can work it out one piece at a time. Okay, so let's do this. Boom here. Boom here. Okay, let me drop this here. And guys, I will post this video to YouTube this afternoon. So in case you need to go back and look at anything, you'll have it there. But it says that each of the following problems, write an addition or subtraction expression and then solve the problem. Okay, it says the hottest temperature ever recorded on a certain state was 121. It was recorded on July 6, 1936. Less than 5 months earlier, the lowest temperature was negative 61. What's the difference between the hottest and the lowest temperatures? Okay, so y'all, I'm not going to worry so much about the dates because that's not really relevant to me. What it's asking me to do is find the difference the hottest and the lowest temperatures. So if you think about a thermometer, think about a thermometer on like a vertical scale, and that's 0 degrees, okay? And we know that the hottest day was 121 degrees, right? And the coldest day, come on, pen. Okay, the coldest day was a negative 61. So the negative 61 is going to be right here. What we're trying to figure out is how far is it from here to there, okay? Now, again, y'all, if I was teaching a group of kids, this is exactly how I would show them. I would do it on this kind of a vertical line, because I would say, well, look, between here and here, isn't it 121? And between here and here, isn't that a 61? So if I want to know how far is it from the bottom all the way to the top, I'm going to take that 121 and I'm going to take the 61 and I'm going to add them together. And so the difference is really 182, right? And so I would come back over here and we would write in 182. We would check our answer and they would say, oh no, what did I do wrong? Oh, it says, okay, write the expression. Okay, so sorry, my bad. It's asked me to write the expression. Okay, so this is what I would do. If I'm going to write the expression, I'm going to say, look, I'm going to take the number 121 and I'm going to subtract the number a negative 61. Okay, because it's asking me to write the expression. My mistake. 121 minus, and I'm going to go parentheses, negative 61. Let me see if it's going to be okay with that. Let's go chickadee check. There we go. Okay, and now it's asked me, okay, what was the difference? And we said it was 182. So there we go. Okay, now, so we're going to write the expressions each time and then the answer. So look, let's look at part B. Part B says the temperature was -5 and then it rose by 25 degrees. What is the new temperature? Okay, so again, I would probably show my students the same way. I would say, look, here's 0 degrees. -5 is right here. And we're going to rise up a total distance of 25 degrees. So I would say, look, -5 plus 25, right? And that's exactly what I'm going to write over here. So -5 plus 25, okay? And then I would tell my students, well, look, where would we be now? And hopefully they would say we would be at 20, right? Boom. Okay, and let's look at part C. Part C says the temperature went down from 44 to -3. How many degrees did the temperature fall? Again, I would try to, again, so the point of this class, y'all, is not necessarily for me just to show you how to do it, but how would you show your students, right? So I would say, look, here's 0. Okay, here's 44. We fell all the way down to a -3. So we fell all the way down over here. So we're going from 44 minus, because we're falling down, a -3. And then we would say, okay, how far did we really fall? We really should have fallen a total of 47 degrees. Okay, so let's do that. Let's go 44 minus -3. There it is. And what? Okay, hit okay. And then, so we fell by 47 degrees. Let's check that. Okay. And then there is a part D. So let's do part D. So it says Brooke's house had a temperature of 50 degrees. She put on the temperature and it rose by 15. Brooke's still cold, so she lights a fire, which increases it another 13. Okay, so again, I would just kind of do the same idea, right? I'd say, look, we're at 50. We rose 15. We rose another 13. Okay. So, oops, sorry. 50 plus 15 plus another 13. Okay, and how much is that going to be? Probably something like 78. It's a little hot, but anyway, there we go. All right, so that was 18. Any other questions y'all want me to go over? Which one? Number 9. Okay, yeah, definitely. Let's do number 9. Let me come back over here and let's take a look at number 9. Okay, so number 9 here, let me go ahead and just copy this one here, y'all, too. Do it the same way. Let me come back this way. Boom. Okay. All right. Okay, let's come back over here and let's take a look at number 9. And let's see what it's asking me to do. It says, okay, if 7 divides n and 5 divides n, then 35 also has to divide n. Okay, so it says use the fundamental theorem of arithmetic to justify parts A and B. Okay, so guys, one thing I told y'all before is you can definitely use your notes for this here. So if you ask me today, what is the fundamental theorem of arithmetic? I'm going to say, I don't remember. So I'm going to come back and look for it. And I want to say, since this test is over chapters 4 and 5, it's got to be in the chapter 4 notes, I want to say. So I'm going to open this chapter 4 notes up, y'all, just because I'm looking for that fundamental theorem of arithmetic. So I'm going to kind of scroll through until I find it. Let me see. And it'll be here, y'all. It's not going to be too far. Here we go. Fundamental theorem of arithmetic. Okay, that's part of it. Let's see. Yes, okay. It says each composite number can be written as a product of primes in one and only way, except for the order of the primes are, order the prime factors in the product. Okay, so what I would do here, guys, is I would come back to this problem and I would say the fundamental theorem states that n can be written as a product of primes. Okay, so right here, y'all, this should say product of primes. Okay, so I'm going to scroll back and I'm going to look at my problem here, and there should be a product of primes. Boom, right there. In one and only one way, since 7 divides n and 5 divides n, then 7 and 5 are both, number one, they're both prime, right? They're prime numbers, meaning, what does prime numbers mean? It means I can't break them down anymore, okay? And they must be included in the unique factorization. Okay, factorization just means the way we break it down, okay? Notice, y'all, we're multiplying here, so that's why everything is multiplied. If you look at these are adding. That's not what we're doing. And then, since 7 times 5 is equal to what number? 35, it's going to divide n, okay? And then there should be a part B. It says, since 4 divides n and 9 divides n, and 4 and 9, think about the number 4. 4, I can break that down into 2 times 2. 9, I can break that down into 3 times 3. So these are the products of different prime factors, meaning 2 is a prime number and so is 3. And they must be included in the unique factorization here. And then again, we're still multiplying. Since 2 squared times 3 squared is equal to 36, it's going to divide n. Okay. All right, part C, it says, is it always true that if A divides n, then B divides n, then A and B divide n squared? It says either prove it or give a counterexample. Okay, so let's take a look here. It says, let A be equal to 2, and let B be equal to 3, and n is equal to 6. So n squared would be, if I were to square 6, that would give me a 36, right? So look, I'm going to put a 36 here. I don't know what the answer is off the top of my head. I'm going to go through it. Okay, and it's saying 36 is not divisible by 2 and 3, but you know what? It is. You can divide 36 by 2 and by 3. So I'm not going to use that one, okay? Let's see. If A is 2 and B is 3 and n is 15, but remember, y'all, these numbers here have to be able to go into this one. And even though 3 goes into 15, 2 doesn't, okay? So I'm not going to use that one there. So my choice is either going to be a C or a D, and I'm going to try to take a look and see if I can figure out which one it is. Okay, if A divides n, then there's a whole number C such that C times A is equal to n. And if B divides n, that means that there's a whole number D, so that D times B equals n. And let's see. DC equals AB n squared, which means that A and B divide n squared. I'm trying to figure out what's the difference between C and D. Okay. That looks right. That looks right. Prime number. That's what we're looking for. The prime number. There we go. That's what the difference is. Man, it took me a little while to figure out. Oh, no, it isn't prime number. Maybe I guess it's going to have to be a whole number then. So there we go. Yeah. So it's a whole number, you guys, because those numbers or those whole numbers D and C don't have to necessarily be prime. They just have to be whole numbers. Okay. 35. Okay, let's take a look at 35. Let me jump over here and let's take a look at 35. Okay, this is a good question. Let me go ahead and copy this guy down. And let's think about it this way. Okay, so let me do this. Okay, so 35, y'all. Let me come back and write it down here. It says a class consists of 1/2 freshmen, 1/8 sophomores, and 1/8 juniors. It says the rest are seniors. What fraction of the class are seniors? Okay, so what I want us to do here, y'all, is we have 3 fractions here. We have 1/2, we have 1/8, and we have another 1/8, okay? So remember, these are freshmen, these are sophomores, these are juniors. We're trying to figure out how many seniors do we have, okay? What I'd like for us to do, y'all, is I'd like for us to rewrite each of these fractions with the same denominator, okay? So again, if I was dealing with a group of kids, right? And I would say, okay, well, look, the first thing we want to do is we want to find the least common multiple between the numbers 2 and 8. And then we would say, okay, look, can we draw the circles? Yeah, we can go through that whole process of drawing the circles. But what I would probably tell my students is, let me come back this way. I would probably tell my students, you know what? Let's use our multiplication table. I'm a big fan of this, y'all. You can see I use this pretty regularly. But I would say, look, let's look at the 2 and let's look at the 8. We're going to go down, okay? And we want to find the first number that they both have in common. Isn't it 8 is the first number that they both have in common? And hopefully your kids would say, yeah, that's my common denominator. So what we're going to do now, y'all, is we're going to go 8 here, 8 here, and 8 here. And we're going to say, look, we had to multiply that one by a 4, so we got to do that one by a 4. We had to multiply this one by a 1, so that one's going to be a 1. We had to do the same thing here, so that's a 1. Okay, so now the way I would do this, again, with my class, I would draw a circle, okay? I'm going to cut it into 8 equal pieces, okay? So I want to say I have 8 equal pieces. So look, for the freshmen, I'm going to use red. 1, 2, 3, 4. For the sophomores, I'm going to use green, 1 out of the 8. For the juniors, I'm going to use like a purplish. Those are the juniors. Who are left over? The seniors. So out of the 8, how many pieces do we have? 2, right? 2 out of the 8. And isn't 2 out of the 8 the same thing as 1/4? Does that make sense how we did it? And like visually, you can kind of get a picture of what's going on. So right here, y'all, I would say, look, this is going to be 1/4. It says to simplify my answer. That's why I'm using 1/4 instead of 2/8. Okay. That's a really good question. And guys, I'll tell you something, like when I'm teaching, like say my Math 100 class, and we do problems similar to this, right? Because again, Math 100 is kind of like, I didn't learn the stuff I was supposed to learn back in school, so I'm kind of having to do it now. Like I never really did this kind of approach before my classes, and I kind of like it. I think it's visual. I think, again, a lot of us are visual learners. We learn that way. And guys, you know, when you end up teaching, whenever you end up getting like your first class and that kind of stuff, you're going to find things that work. You're going to find things that don't work. Okay. I guess the biggest thing I can tell you is experiment, try to do stuff. Okay. It's okay if you try something and it doesn't work. It doesn't mean that you failed. It means that you tried something that you thought was going to work and it didn't, but now you know, okay, this is not, maybe this is not the best approach. Okay. Let's see. Any other questions y'all want to ask me about anything? 39. Let's take a look at 39. Okay, it says choose the number that approximates each of the following. Okay, so look, y'all, this is how I'm going to sort of think about this process. 3 4/9. I'm trying to figure out, is this number here, is it closer to 3 or is it closer to 4? Okay, so if I were to double this numerator here, so if I were to double the 4, I would give me an 8. Okay, that's not bigger than my denominator. So the 4 out of 9 is less than half. So I'm going to think of this number as maybe a little bit closer to 3. Okay, if I were to double this numerator 4, that would give me 8. That's already more than what I have on the bottom. So this 7 4/7, I'm going to say that number is closer to 8. So if this number here is closer to 3 and this number here is closer to 8, 3 times 8 would give me something about 24. So I'm going to say, look, this is going to be closer to 24. There we go. I'm kind of trying to estimate, okay? What I mean by estimate, y'all, is I'm trying to figure out, is this number, is the fraction part, is it closer to 4, is it closer to 5? The easiest way to think about that, look at the number on top. The number on top is a 7. If you double that number, if you get more than what you have on the bottom, then round this guy up. So I'm going to say that number there is this number here. If I double 7, it's 14. That's already more than what I got on the bottom. So I'm going to think of this 4 7/12. I'm going to think about that as a 5. If I were to double the 17, that's going to give me 34. That's still way smaller than 100. So I'm going to think of this number as 7. So if this is a 5 and this is a 7, 5 times 7 would give me 35, right? And I'm going to check that. Okay. And I'm going to do the same thing for this one. Now, the only thing I'm doing here, y'all, we're dividing. So look, let me do it this way. Okay. Let me do it this way. Let me copy this guy. And let me drop it right here. Let's drop it like it's hot. Okay. So remember, when I'm dividing fractions, y'all, the way we divide fractions is we take the first fraction and we multiply it by the reciprocal. Okay. So look, 103 over 102. And the way I would think about this problem is, again, if you were showing this to your students and you'd say, look, how would I go about converting this, say, to a mixed number? And we would say, well, okay, if we're going to convert it to a mixed number, we would say we're going to take 102 and we're going to divide it into 103. And how many times is it going to go in there? It's going to go in there once, right? And how many am I left with? I'm left with 1. I'm left with 1 out of 102, okay? Now, again, I would look at this thing and I would say, is this number here, 1 and 102, is this number here closer to 1 or is it closer to 2? And I would say that number is really closer to 1. And if your students were to say, sir or miss, how do you know it's closer to 1? And this is what I would tell my students. I would say, look, suppose you owed me $102 and you're going to pay me back. And you've given me $1. Have you really put a dent in how much money you owe me? No, not at all, right? You give me $1 out of 102. It's like you haven't really done much yet. So what am I left with? The number that I have in front, which in this case is a 1. So I'd come back over here and I'd say, you know what? My answer here is much closer to 1. Right? There we go. Any other ones, y'all, about anything? Which one? 38. Let's take a look at 38. Okay, it says find each of the following products and then write the answers in simplest form. Okay, so let me copy this here. And again, the one thing I will say, y'all, about this particular problem, the first part is definitely more of an elementary school, what you would see in an elementary school class. And I mean, again, when I say elementary school, you know, you're not doing this in 2nd grade, but you're definitely doing this in probably 4th or 5th grade, you know. But this would be the approach on how I would show my students, okay? So part A, we have the number 41 we have a 99 here, we have a 77, and we have 123. Okay. So again, if I was dealing with my students, excuse me, the first thing I would do, y'all, I'd come back and I'd look at my chart. Okay. So I'm going to look at the number, say 99. Okay. And if I look at my multiplication table, I'm going to say, look, I see a 99 right here. And the two numbers that I know multiply to 99 are 9 and 11. So I would say, look, I'm going to rewrite this number here as 9 times 11. And I would do the same thing with my students. I'm going to say, look, I'm going to think of that number as 7 times 11. And then I'm going to see if I can break down either 123 or 41. So I'm going to come back to my chart. And I don't know if there's a 41 or a 73 in there, but I'm definitely going to take a, or 123. But I'm going to take a look and see if I can find either a 41 or a 23 anywhere. Or 123, I'm sorry. 41. And I don't know about you guys, but I'm not seeing a 41. I'm not seeing a 41 in my chart at all. And I'm not really seeing a 123 in my chart either. But I want to just double check. Now, it doesn't look like I am. Okay, so those numbers there, y'all, probably can't be broken down. But what I would show my students, I say, look, any number on the bottom can reduce with numbers on the top. So those would go away. Okay, so what does that mean I still have? I have a 7 times a 41. So 41 times 7, right? 287. And then 9 times 183, or 123, I'm sorry, is 1107. Okay, and I'm just going to check one more time, y'all, just to make sure I didn't miss anything here. No, it didn't look like it. Okay. So yeah, that's what my answer should be. My answer should just be 287 over 1107. So let's try that here. 287 divided by 1107. Let's see if we get that right. Oh no, even though it's a correct answer, it's not in the correct form. Okay, all that means, y'all, is that I should be able to reduce something here. What else can I divide this by? Oh my goodness. You know what? I'm going to try one other thing, y'all. 123, I'm going to see if I can divide it by 41. Ah, we can. Okay. So look, right here. That was my mistake. Come on, pen. Okay, this is what I would tell my students. I didn't see this. This is really 3 times 41. So that 41 and that 41 are going to cancel. So there's a 1 there. So 1 times 7 is a 7. And 9 times 3 is a 27. So that's what I should end up with. Come on, pen. 7 over 27. Okay, there we go. I didn't see that. So right here, let's fix this. 7 on the top. 27 on the bottom. There we go. Okay. Now, for parts B and C, y'all, this is definitely more junior high level, or maybe, I mean, I don't know. I mean, I can't say that it's in 5th grade. It could be, though, if you get an advanced group. But what I would show my students, the way I would do part B, I would write a y here and a z, because that's what we got. Okay, a z squared really means that there are just 2 of them. And a y squared, again, means that there's 2 of them. And I would show my students, look, one of these z's on the bottom is going to cancel with one of those on the top. And this y on the top is going to cancel with one of those y's on the bottom. It doesn't really matter which one. And what's the only thing I'm left with? I still have a z on the top and I still have a y on the bottom. And that would be how I would show my kids, right? So I'd come back over here and I'm going to say, look, we're going to take z divided by y. There we go. And then I'm going to do the same thing for part C, y'all. So again, if I was showing this to a group of kids, right? I have an M, I have an M and a B and a W right here. And I have a W squared, which just means I'm going to write 2 of them and an A. And then I have an M to the 3rd, which means I'm going to write 3 of them and a B squared, which means I'm going to write 2 of them. And then I would play the same game. I would say, look, this M here will cancel with one of those. Let's get rid of that. And this B here will cancel with one of those. Let's get rid of that. And this W here will get rid of one of those W's. Let's get rid of that. So what's the only thing I'm still left with on the top? A W and an A. And on the bottom, I have 2 M's. So that tells me that's an M squared and then a B. So I have a W and an A on the top and an M squared and a B on the bottom. So WA divided by M squared, and then a B on the bottom. We got it. Any other questions, y'all, about anything? Y'all, one thing I will say, whenever you end up teaching, try to have fun in class. Try to have fun in your classes. I know there's like, there's going to be an objective, right? Like, okay, I got to make sure I do this stuff, and I got to make sure I do that stuff. But whatever it is you do, try to have fun, right? Especially when you're dealing with, elementary school kids, and even if you end up teaching like a 6th grade math class or whatever, or 6th graders, whatever it happens to be, right? Try to have fun with whatever it is you're doing, guys. I mean, I think, I don't know about your experiences in elementary school, but like, do I remember them teaching me phonics, how to pronounce words? Yeah, I remember some of that stuff. But you know what I remember the most? The fun days, field trips, right? Did y'all ever play 7-Up where you put your head down? That's the kind of stuff that you remember, right? So, and I mean, did we learn stuff in elementary school? Of course we did. That's how we learned, we learned our ABCs, right? We learned how to spell can and cannot, and we learned how to spell mountain and all that kind of stuff. We learned how to spell words, and we would have to read in class, and okay, now you're going to read next. We all learned that kind of stuff, right? But, what I'm going to go ahead and I'm sorry, before I go on, any other questions? No? Okay, let me go ahead and stop recording. But guys, the best thing I can probably tell y'all is just try to have fun in class. Try to make the experience for your students like the